Oh, you thought I was done today. You forget, I am never done. Also, I think I might have a problem with recording lectures. I find that once I start, the more I don't want to stop. But I thought this was pretty important to cover because I wanted to make sure that we had a nice little refresher for sampling, especially considering that the last time we talked about sampling, it was before spring break. And frankly, how many of you feel like that was at least in my mind, it feels like it was 20 years ago at this point. That's how far removed we are from that reality now. And your textbook makes sampling an entire chapter, a pretty short chapter, but a chapter nonetheless. So I thought with the time that I had in my schedule, I would go ahead and give you a brief refresher on sampling. So let's go ahead and begin. So here's what we're largely going to talk about today. So I've kind of talked about these concepts before, but I think they do actually bear some repeating here. So first of all, we are going to talk about sampling and generalizability. And then we're going to talk about how that applies to external validity. So just as a reminder, external validity is basically, do the results of this study actually tell us more about humanity or about people beyond this particular very specific scientific study? So how much does it generalize across other settings, other people, other times, things like that? So we're first going to start by talking about sampling and generalizability. So how can we, is there a way that we can actually see if our results generalize to a larger population based on the sample that we pick? So picking a good sample is really important. So if we're going to look at a pre-election poll, will the results actually tell us anything about what we can expect in the actual election? And the truth of the matter is, it depends. It depends on what your sample is. And also, it depends on who you're trying to extrapolate to. So I often find that when we look at these different types of pre-election polls, they are not necessarily all looking at the exact same sample, and they're certainly not necessarily also looking at the same population. So are we looking at all registered voters? Or are we looking at all voters who actually do vote? We know that a lot of people are registered to vote, but they don't necessarily vote. They don't actually go out and do it. And so if we're looking at all registered voters as our sample, and we're trying to extrapolate to all voters who will actually go vote, there might be some important differences between people who vote and are registered to vote and actually go do it versus people who are registered to vote but don't. Are we looking at likely voters? Are we looking at undecided voters? Undecided voters may not necessarily have a decision when they actually go vote. But in a pre-election poll, if you force them to pick, they have to pick one. But that doesn't necessarily mean that they will go out and vote for that person in the actual election. So picking a good sample is really important, because if you pick a bad sample that's unrepresentative of your population of interest, you can't really draw any sort of conclusions. You can't really make the kind of predictions that you want to make, and that's a problem. So let's just quickly do a review of the different definitions when we talk about populations and samples. So a population is an entire set of people or things that you're interested in studying. For example, all freshmen that are currently enrolled at Cuddy College. A sample is going to be a smaller group. It doesn't necessarily have to be smaller, but it could be smaller, and often is, because typically you can't sample everybody. A smaller group is a sample. It's drawn from the population of interest. So 25 freshmen that are currently enrolled at Cuddy that responded to an email. So that is a smaller group of our actual population of interest. Now, occasionally your sample ends up being the entire population of interest. And in those particular instances, those are what are actually known as a census. So I did talk a little bit about a census when we talked about surveys in the lecture that I posted. So part of the reason that we call it the census is because pretty much, if I'm not mistaken, about 90% of the population in the United States responds to this. They are required by law. And that other 10%, if I'm not mistaken, typically doesn't really add much more than that, but we try as much as possible to get everybody in the population to take part in this. That's part of the reason why it is enforceable by law. They actually want this to be a for real, no fooling census. Okay. So how you choose to select a sample will determine if your sample is biased or unbiased. So your sample's only going to be as good as the means that you use to actually select that sample. So here we have, your book has some examples of some biased and unbiased samples of different populations of interest. So let's say our population of interest is Democrats in Texas. Let's start by talking about what an unbiased sample would look like. Get a list of all registered Texas Democrats from public records. Call a sample of them through randomized digit dialing. So we are basically trying to get a simple random sample of all registered Texas Democrats. Odds are pretty good if we have a sufficiently large group of people and we're also utilizing random sampling. Odds are pretty good that that sample is going to be representative of the larger population. On the other hand, a biased sampling technique would be looking at people who are in the front row at the Texas Democratic Convention and recruiting them. Now, typically people who are at the Texas Democratic Convention are usually going to be delegates. They are usually pretty die-hard supporters of the party. So they are not necessarily representative of everybody in Texas who is registered as a Democrat. And because of that, because of this sampling technique, you might actually get something that is a little bit more extreme than if you actually looked at people who are not at this convention. Here's another example. Drivers. So an unbiased sampling technique would be to obtain a list of licensed drivers in each state and select a sample using a random number generator. Again, that's a very good method for getting a simple random sample. Here is an unbiased sampling method. Asking drivers to complete a survey when they stop to add coins at a parking meter. So first of all, not every driver is necessarily going to be parking in a place that has a meter. Maybe there is something fundamentally different about this group of people that have to park at a meter. Maybe they work there. And so they might fundamentally be different from people who are not using that meter. And so again, we could have a biased sample. All right, students who have taken a class with Professor A. Obtaining a list of all of Professor A's current and former students, selecting every 15th student for study. Another good, simple, random sample. On the other hand, let's go to something like Rate My Professor and only include students who have written comments about Professor A. Generally, when you go to websites like Yelp or Rate My Professor, this is a self-selected sample, and typically people who write reviews online are writing reviews online because they either really love it or they really don't like it. So you're not really going to find a lot of people who are just like, yeah, they were just okay. You're typically going to find people who are either really diehard for Professor A or loathe Professor A. And you're not really necessarily going to get anything in the middle. You're not going to get the middle of that curve. You're only going to get the extremes. So once again, pretty biased sample. So how do we figure out if our sample is biased? I'm sure that some of you might be familiar with the Jeff Foxworthy bit, "You might be a redneck." I'm going to go ahead and co-opt that for a little bit. We're going to call this, "Your sample might be biased." If you're using convenience sampling, your sample might be biased. So here's kind of an example of what I mean. So what you're looking at here, oh, where'd I go? Oh, hey, there I am. So if you're using convenience sampling, odds are pretty good your sample is likely biased in some way, particularly if you're just getting the people who are easy to get. And so here's some evidence that you can kind of use to kind of see some of those differences. So this is based on a U.S. Department of Health and Human Services survey, data that's basically collected from July 2015 to December 2015. The number of people in this survey are about 15,988. That is a great survey with large N. Do not forget that just because something is large N, we like large N, we want large N for Christmas. But just because we have large N doesn't mean that our sample is unbiased. We have to look at the sampling method. So what you're kind of looking at here are different health indicators. Are they a current smoker? Have they had at least one heavy drinking day in the past year? Have they received the flu shot? And so here we've got landline only or landline and wireless. Here we've got wireless only. Here we've got no phone at all. So landline only or landline and wireless basically make up about 48% of the people who were surveyed. People who were wireless only are about 48.3%. So about we're kind of split. And then we have about 3% that have no phone at all. So let's take a look at how different the data are between these groups. So for our landline only and landline and wireless groups, about 11.5% are current smokers. 18.8% of wireless only households are, and about 20%, over 1/5 of no phone at all of this 3% are current smokers. So again, if we're only looking at people who are easy for us to get, we're not necessarily getting the full picture. You can see that we have a similar sort of thing with heavy drinking day. We see some differences between these groups, and the same is true for people who are actually getting the flu shot. So what this tells us is that if we're only considering people that have a landline, or if we're only considering people who are wireless, we are not getting a full picture of the data. And the same is true if you are collecting data from online means. So I know that a lot of people to collect online data use things like Amazon's Mechanical Turk. You put a survey online and people complete it for money. You can do something called Prolific Academic. And just like we see with telephones, one of the things that we do find is that there are some fundamental differences in terms of personality traits, wealth, access between people who are completing things like Mechanical Turk versus people who don't. And you can actually see some citations from people who have actually shown that there are some sample differences between people who are using Mechanical Turk and people who really aren't. So again, your sample is only going to be as good as your selection method. Okay, here's another one. If your participants are self-selecting, your sample might be unbiased. So what you're looking at here are surveys on car seat usage and road rage. So will you keep your child in a rear-facing car seat? For safety's sake, the American Academy of Pediatrics says kids should ride in a rear-facing car seat until they outgrow the height or the weight limit, typically around age 2 or 3. Do you plan to follow this advice? About 58% say yes. 23% say no. I'll turn my child forward facing before age 2. And I'm not sure for a remaining 19%. So about 42% of people don't plan on following those guidelines. But what we do tend to find is that, at least for this case, this is an instance where, despite the fact that we have 19,000 votes, this was an online self-selected survey. So the only people who are filling this out are the people that want to fill this out. And there might fundamentally be something different about the people who are filling this out versus the people who aren't. And so again, we can't really extrapolate to the larger population here. Now, let's take a look at this road rage survey. Nearly 80% of drivers expressed anger, aggression, or road rage behind the wheel at least once in the past year. This is a 2016 survey. 3% ram or bump another vehicle on purpose. That's really good for your insurance. 4% get out of the vehicle to confront a driver. 12% cut off another vehicle on purpose. 24% block another vehicle from changing lanes. 33% make angry gestures. I'm a fan of the sarcastic thumbs up. 45% honk. 47% yell. 51% tailgate on purpose. So again, your sample is only going to be as good as your sampling methods. And at least in this case, we can actually trust this survey. The road rage survey was actually randomly selected from internet users. So does this potentially change how we view it? Yeah. Odds are pretty good. People are pretty angry behind the wheel. Got to watch out for this 3 and 4% that actually really get aggressive. Keep an eye out for those types. So if you want an unbiased sample, engage in probability sampling. Oh my, something very interesting is happening over here. You should see this. Look at that. Look at that. Maybe I should give him a survey, y'all a survey on what you think he's actually doing right now. Please don't eat my planner. I know you want attention, but don't eat my planner. So with the probability sampling occurs when every person has an equal chance or a probability of being included. So one of the most basic ways that we can actually do this is with a wonderful, simple random sample. So a simple random sample, this could be where we basically assign a number to every participant, and we can actually utilize a research randomizer that randomly generates numbers. That gives us our sample that we can draw from, or we get a pool of all listed people and we pick every nth, every fifth, every third, every 15th, or so on. Now, here are some other types of probability sampling. Some of these we've talked about before. Your book has some slightly different definitions or names that I've used, so I kind of want to clarify those a little bit. So we have cluster sampling. So we've kind of talked about this before. We identify units or clusters. So, for example, the different suites at Cotty, and then we randomly sample from that list and we survey every single person within that randomly selected cluster. Now, on the other hand, you can do what your book calls multi-stage sampling. Same sort of idea here. You identify all of the units or clusters in your population of interest. You randomly sample to select your clusters. And then once you have your clusters, you randomly sample the people that are part of those clusters. So cluster sampling, you're sampling everybody within a randomly selected cluster. With multi-stage sampling, you're randomly sampling people that are in those randomly selected clusters. We have stratified random sampling, so we divide people into different groups such as freshman, sophomore, junior, senior, and then randomly select people from each of those different groups. One of the things that we can actually do is something called oversampling. So especially when you're dealing with demographics, there are some cases where some groups are very, very small, or they're very, very small percentages of the population. So what you might want to do in those particular cases is overrepresent them in your sample. So if we are, for example, interested in let's say super seniors, so people who have been at Cotty for more than 4 years. And those typically will comprise a very small part of the population. Instead of randomly sampling them, I may choose to include all of them. So that way I get a better idea of how that smaller group thinks. Your textbook gives an example of the fact that, for example, let's say that we want to look at the demographics for Pacific Islanders. They typically will make up a pretty small sample of the population. They make a small percentage of the population. So if I'm only getting like maybe 10 of them, or even 40 of them, I'm not necessarily getting a full demographic view of them. I'm not getting a very representative sample of them. So I might deliberately select 100 of them so that I have a better idea and I have a more representative sample of that particular group that is typically smaller in the population. I can also do what is called a systematic sample. I can use systematic rules to obtain my desired sample. So let's say that I have 2 different dice. I roll a 5, and for the second dice, I roll a 3. So maybe what I do is with the first dice, I start with the 5th name in my list of potential participants. So I start with my 5th name in the population, and I pick off every 3rd person until I have the sample size that I want.